Next, a member subjected to expression for member stresses when a member subjected to a biaxial stress. Biaxial stress are two like principal stress. Two like principal stresses. So in the last class we had this sketch. The same sketch we'll be taking. So we consider a plane of cube with unit thickness. Let us consider a plane in a cube of unit thickness, and let me call that plane as AB, CD, right? ABCD is the so I'll consider a plane AB, C, D, and I need to find the stress on this inclined plane. So the stress acting is two stresses. Let me take it is subjected to stress sigma 1 in x direction and sigma 2 in y direction. The x direction will be the major stress, a y direction will be the minor stress. A y direction, x direction, the major principal stress will be x. In a problem, there will be major stress and minor stress. In x direction, whatever stress that comes, that will be the major stress, and in y, that will be the minor stress. So that is subjected to stress in x direction and stress in y direction. So this is a plane of unit thickness. It is a plane of unit thickness. So here I will take. So here I will take a plane to derive the expression for stress acting on the plane. So let me consider some plane E, which is inclined at certain point, which is inclined at certain angle theta, right? And over this inclined plane, there exists always a two stress. One is a normal stress, another one will be the shear stress. So the normal stress is always acting perpendicular to the, it is always acting perpendicular to the, it is always acting perpendicular to the plane. So this is the plane EB. So the normal stress is sigma n. Okay. And the shear stress is always parallel to the plane. It is always parallel to the plane. So take a shear stress. So that is always parallel to the plane. So this will be sigma T. Shear or tangential stress. Call it as shear or tangential stress. So that is sigma T. So whatever the sentence I told, that has to be written in words. So we have considered a rectangular block of plane or cubical block inside which we have considered a plane of ABCD whose thickness perpendicular to the plane is unity. The thickness is unity. And the block is subjected to the principal stress sigma 1 and sigma 2 principal stress. So if it is a principal stress along this plane, there is no shear stress. Since it is a principal stress, the definition of the principal stress, so the principal stress exists in a principal plane where the shear stress is zero along the plane. So here in this AB, there is no shear that exists, and DA, there is no shear. So I need to find along the inclined plane, when this plane is inclined at certain angle, so when it is inclined, there exists a shear along with normal stresses. Okay. So this is the Remember, it is subject to biaxial stress. That is, in x-axis one stress and y-axis the other stress are two like principal stresses. Okay, so I think you've taken this. So now let me resolve these forces. Resolve the force on the plane EB, on the plane EB. So I can show it here itself. So it is subjected to sigma 2 it is subjected to, or let me show it separately. It's no problem. Sigma 2. Okay. So now let me consider this plane ABE triangle. So I need to resolve the force with respect to the inclined plane. So with respect to inclined plane, so there is a normal stress here. There is a normal stress sigma n, and we have a shear stress sigma t. So whatever the forces which are going in this particular direction, if it is going in this direction with respect to normal stress, we'll take this as positive. This will be positive. And whatever the tangential stress or shear stress going in this direction, we'll consider it as positive. The direction which is opposite to this or this, that will be considered as negative. Okay. So now let me resolve the, we have already resolved the force in x direction in the last derivation. It is exactly the same, nothing changes. So we have sigma 1. So let us start a resolution. So the resolution principle is, if it is going as I told, in some of the direction, if you take a if you resolve the forces, it should complete the loop. It should complete the loop. So that the arrow mark will be coinciding with the force or stress which is acting, right? So now let me resolve the tangential force. So take a line parallel to the tangential force, and draw it on the stress that is acting in the x direction. So this is the line which is tangential to the, or which is parallel to the, tangential stress. So draw the arrow mark. So now from this end point, or from the starting point of the sigma 1, you draw the line parallel to the normal force. Now let me resolve the normal force. This is the normal force. So I'll draw the line parallel from this point, which is parallel to this normal force. So draw the arrow mark. The arrow mark should close the loop. So it starts with this point and it will be closing with the stress which is acting. So you can do it in this direction, or if you do it in the other direction, if it is sigma 1, so you can start with normal force itself. If you start with normal force, you start with the starting point, it should be like this. So this is the line parallel to normal force. Next, from this end point, you draw the line parallel to tangential force. It is from this, take a line parallel. From this point, you draw this line is parallel to tangential force. Now the arrow mark loop should be from the upper direction. That is in clockwise direction. Here it is an anti-clockwise direction. Okay. So this is the method to resolve. Okay. Now from the geometry, this will be theta. So this angle would be theta. So we have done it in the last class. So the opposite angle, this will be sine, or it is sigma 1 sine theta, and this adjacent will be sigma 1 cos theta, right? So similarly, I need to resolve the force in the y direction, So the force in the y direction, it is sigma 2. Okay, same method. So now you draw the, either you start it to the right hand or left hand, that is left to you. So if you are starting with right hand, you should take normal stress first. So take a normal stress line which is parallel from this end point, draw the line. So this line is parallel to, this is parallel to the normal stress, normal stress. So just complete the arrow mark direction. You go in clockwise or anti-clockwise. So if I'm going in the right hand side, I'll be going clockwise. So this will be parallel to normal stress. Now you draw the tangential line parallel from this end point. Okay. So this line is parallel to this tangential stress. So you just complete the loop. So this angle will be, so this is theta. This is theta. So if this is theta, so if you go, this will be theta and this angle will be theta. This is by the geometry of the sketch. So this angle would be theta. So now you just resolve the force. The opposite line, this will be sigma 2 sine theta, and this adjacent will be sigma 2 cos theta. Okay, so now the method is similar, only we have one additional stress that is acting, and we have resolved that component in that particular direction. So whatever the stress, you should resolve with respect to the inclined plane and the tangential and normal stresses. So now under equilibrium, let us consider under equilibrium, a sum of normal force is equal to 0. Sum of normal force is equal to 0. So we have the normal force here. One is with respect to normal stress. As I told, the force is equal to the last stress. It is stress into area. So here the stress acting is sigma n. It is acting on a plane EB. It is acting on a plane EB, and we have to take the area of this plane. The area of this plane is EB. EB is the weight that is into its thickness. Thickness is unity. We have considered the thickness as 1. Okay. So that will, we will take the stress in this direction as positive, which is going in sigma n as positive. The opposite stress will be negative. So it is sigma n EB into 1. Right? The force in this direction with respect to normal stress. Next. So whichever the force what we resolve that is parallel to normal stress, that we need to add here. That we need to add. The direction which is going in this direction with respect to normal, we take it as positive. The opposite direction, we take it as negative. Okay. Next, which is the stress parallel to this? In this sigma 1, it is sigma 1 cos theta. So it is going in opposite direction to sigma n. So we'll take it as negative. So it is minus sigma 1 cos theta. It is acting on the plane. What is this plane? AB. It is acting on a plane AB. So its area is AB into 1, right? AB into 1. So only we have one normal stress in this x direction, and we have one more normal stress in the y direction. So which is parallel to this is this component, and it is also going in the opposite direction. So it is sigma 2 sine theta. So it is also minus sigma 2 sine theta AB into 1. Now I just rearrange this. You just rearrange these components. Therefore, sigma n will be equal to sigma 1 cos theta into AB by EB minus sigma 2 sin theta into AB by EB, right? So from this triangle, so what is AB by EB? From triangle AB, some triangle ABE, AB by EB is since it is adjacent, AB is adjacent, EB is hypotenuse, AB by EB will be equal to cos theta, right? AB by, so sorry, here I got a mistake. So this stress sigma 2 is acting on the plane EA. Sigma 2 is acting on the plane EA. So this area should be, it is not AB, it should be EA. It is EA. Since it is acting on this EA plane, you should take an area of this plane. Okay. So from this triangle, AB by EB is cos theta, and EA by EB is opposite angle is sine. So EA by EB is sine theta. Okay. By from triangle ABE, so we can write sigma n is equal to sigma 1 cos theta into cos theta minus sigma 2 sin theta into sin theta, right? So it will be sigma n is equal to sigma 1 cos square theta plus agutalva, since it is going to the other side, it is plus, not minus, right? Sigma 2 sin square theta, right? So now we can use a relation for cos square theta is equal to 1 plus cos 2 theta by 2. So we can rewrite this sigma n is equal to sigma 1 into 1 plus cos 2 theta by 2. Cos square theta, I can write 1 plus cos 2 theta by 2 plus sigma 2 into 1 sin square theta can be written as 1 minus cos 2 theta by 2, right? That can be written as 1 minus cos 2 theta by 2. So now you take a common terms outside. So this will be left with, so if you multiply sigma 1 inside, if you take a common terms outside, you will get the equation for normal stress is sigma 1 plus sigma 2 by 2, sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma 2 by 2 into cos 2 theta. So this is the equation for normal stress or biaxial stresses, are two principal stresses which are acting on a plane. Okay, you need to remember the equation. So now we resolved horizontal force, normal force. Now we need to resolve a tangential force to get the equation for tangential stress. So let me, under equilibrium condition, now let us resolve a tangential force. So let us resolve this tangential force. So that is next. The sum of sigma ft, that is sum of the tangential force to 0. Let us equate the sum of tangential force to 0. So we have the tangential stress is one is sigma t, which is acting on a plane EB, So you take a force acting on that plane EB, that is sigma t into EB into 1, right? We'll take a force that is going in this direction as positive and reverse direction for this with respect to that as negative. So now what is the tangential stress in x component? So which is parallel to sigma t, which is this line. So this component is sigma 1 sin theta, and it is going in the opposite direction. So it is minus sigma 1 sin theta, and it is acting in a plane AB. It is acting on a plane AB. So its area is AB into 1. So next, the stress acting in tangential stress along y direction, which is parallel to sigma t, is this component, and it is sigma 2 cos theta. It is acting on a plane EA. That is also going in same direction, right? So you can see it here. It is, since sigma t is going in same direction, and also this sigma 2 cos theta is also going in the same direction as sigma t. So it is positive, whereas here it is going in opposite direction, it is negative. Okay. So it is plus, it is not minus. Why? Because plus, it is going in the same direction. Plus sigma 2 cos theta, it is acting on a plane EA. So it is, area is EA into 1. That is equal to 0. That is equal to 0. Now you just rearrange the terms. You'll get a, just cross multiply, rearrange and cross multiply. So just we'll reduce this equation. Sigma t is equal to, so sigma 1, it is going to the other side, it will become plus sigma 1 sine theta into AB by EB. So this is going to the right hand side, it is minus sigma 2 cos theta into EA by EB, right? So now from the triangle, same thing. AB by EB is cos theta, EA by EB is sin theta, right? So this will be equal to sigma t will be equal to sigma 1 sin theta, AB by EB is cos theta minus sigma 2 cos theta, EA by EB is sin theta, right? So you just divide both the sides by 2. Add and multiply and divide it by 2, the above equation. So it becomes sigma t will be equal to sigma 1 minus sigma 2 by 2 into sin 2 theta. So this is the equation for tangential stress. You need to remember to solve the problem, right? And resultant stress equation is given by resultant stress, that is same as what we have done, that is sigma r will be equal to root of sigma normal square plus sigma tangential square. Remember this is general equation. And you need to find when the stress is maximum, when the normal stress is minimum. When will be maximum and when it will be minimum. When it will be minimum. Right? So we have normal stress here and tangential stress. And this is the plane EB. And to this plane, we have a normal stress, sigma n, and a tangential stress, sigma t. And to this, we had a resultant stress that is acting with respect to a normal stress. There is a resultant stress that will be acting with respect to a normal stress. So this is the resultant stress, sigma r. And this will be at an angle with respect to a normal stress. The resultant stress will be at an angle with respect to normal stress at phi. This will be sigma 1. This will be sigma 2. If in the problem there, if it is asked to plot the direction of resultant stress, so you need to make use of this scale. And also if it is asked to find the inclination of resultant stress with principal stress. So the sigma 1 is the principal stress, major principal stress. If it is asked to find the inclination, so you draw the horizontal line. You draw the horizontal line to sigma 1. Sigma 1. Then this will be the inclination of resultant stress with principal stress, with a principal stress. So this will be alpha. Alpha. Alpha is the inclination of resultant stress with principal stress. So this will be a sigma 1 and this vertical will be sigma 2. Sigma 2. And inclination of resultant stress with principal stress, it is given by tan alpha. Tan alpha is equal to inclination of sigma r with respect to sigma 1, that is principal stress, that is tan alpha will be equal to is opposite sigma 2 by sigma 1. So in the problem, if it is asked, you also need to remember these equations, right? So when you know we have already written the inclination with respect to normal stress, that is phi. Tan phi is given by, it is obliquity. We call it as obliquity. Tan phi is equal to, so this is the inclination phi. So this is with respect to the normal stress and tangential stress, that is equal to sigma t by sigma n. This is similar way what I was written in the last derivation. There is no change. This is one additional, it gets added. Inclination of resultant with respect to principal stress. Next. So when the maximum normal stress will be maximum and when the tangential stress is maximum, that you need to write at last. So when we have maximum and minimum normal stress. So when it is maximum, if you look at the equation, so we have a cos 2 theta, cos 2 theta, right? So when is cos 2 theta will be maximum? When it will be maximum?
Theta equal to 0.
Yeah, when theta cos point should be equal to 1. ಅದು 1 ಬಂದ್ರೆ cos 2 theta 1 ಆಗಬೇಕು ಅಂದ್ರೆ cos theta should be equal to 0 or it should be equal to 180 degree. So when I substitute theta is equal to 0, I will get cos 2 theta 1, or when I substitute theta is equal to 90 degree, it becomes 180 degree, right? So it becomes maximum. So there are two conditions. It is maximum when theta is equal to 0 and theta is equal to 90 degree. If you substitute this, theta is equal to 0, theta is equal to 0, that is sigma 1 will be equal to what? Only the first component. It is sigma 1, right? If you substitute, that, theta is equal to 0, then sigma n will be equal to what? Sigma 1. So this component becomes 1. So this component is becoming 1 when theta is equal to 0 and theta is equal to 90, right? When theta is equal to 90, that becomes minus 1, right? When theta is equal to 0, this becomes 1. When theta is equal to 90 degrees, this becomes minus 1, right? If you just multiply these terms with 1 and multiply this with minus 1, you will end with, when it is 0, you will end with sigma n will be equal to sigma 1. Sigma 2 terms will get cancelled. You will get 2 times sigma 1 by 2. Then 2 gets cancelled, you will be remaining with, you just do it by yourself, you will be remaining with sigma 1. So when theta is equal to 90 and when theta is equal to 90, you will get sigma n is equal to sigma 2. Just cross check. When you multiply with that 1 and minus 1. When theta is 180 degree, it happens, it is minus 1. You will get sigma n is equal to 2. So this is maximum normal stress. Then maximum shear stress. So this is the equation for shear stress. So when is sine 2 theta becomes 1, theta becomes 1 when theta will be, that is sine theta component becomes 90 degree, right? So when it becomes, since it is 2 theta, when it becomes 45 degrees, you will get sine 90 and sine 270. So it has to 270 and 135 above. So when theta becomes is equal to, so this is minimum stress. This is minimum and this is maximum. When theta becomes what 45 degrees, theta becomes 45 degrees, this component is 1. So sigma t maximum is equal to sigma 1 minus 2 by 2, right? Right? So in both the cases, sigma t, when it is theta is equal to 270, substitute, when it is 270 r 45. It is not 270, it has to become 270 under, it is 135 degree. So you just remember only two equations, these things can be written. One is normal stress equation, one is tangential stress equation. So these are general equations. So whatever the problem, resultant stress equation is common and obligate equation also is common. It is tan phi, it is sigma t by n. Remember this, two equation is general equation, whatever the conditions. So these equation will be changing, sigma t and sigma n. Put down the equations, whichever we have done in the last class. Normal stress equation for uniaxial stress, and this is for biaxial stress. So if the problem is uniaxial stress, you should use those equations. If it is biaxial problems, you need to use this particular equations. Okay. So we'll just, and also note down one major thing while solving a problem, they will give the angle of inclination. They will give the angle of inclination. As I told in derivation, if it is a block, so this will be, the x-axis will be a major stress, and y-axis will be a minor stress, plane, minor stress. So that is important. The inclination will be given with respect to major stress or a minor stress, major stress or a minor stress. So maybe you can take a simple problem. First, with respect to first derivation, you can take this problem. It is a direct equation you need to substitute, and you should remember these equations. You can note down this first problem. So I think you're taken the problem. So you need to use the equations what derived in the last class. I'll just, I'm not- okay. Kindly note down, this is very important. So whatever the problem given, so this a major stress or major stress will always be acting in a minor plane. That is, vertical axis will be the minor plane, horizontal axis will be the major plane. So note down this in a note. So if it is whatever the angle of inclination, if it is given, that is, this is the problem. If this is the plane that is given, the inclination is like this theta. So this is theta is the inclination with respect to this minor plane or the major axis. Major axis. If that is the condition, you need to consider theta as this 90 minus theta. So if theta is something 40 degrees given, then theta will be equal to 90 minus 40, right? That is 50 degrees. Got it? Next. If the inclination is given with respect to this vertical, that is minor stress or major plane. So that is, the inclination will be given with respect to this vertical. So like this, theta. So in that case, you consider substitute the theta in the equations, direct theta, whatever it is given, whatever it is given. So this is the major thing. If this step goes wrong, the entire problem is wrong. Got it? So note down in a note, note down in a note. If it is with respect to x-axis, inclination is given, it should be 90 minus theta. The inclination with respect to vertical, if it is given, it should be directly theta to be substituted, whatever given. Okay, in the current problem, they are given the inclination 60 degrees with respect to the x-axis. So I'm not completely, I just tell how to solve. They are given P. P is the force you need to find. It is inclined at certain plane 60 degrees. 60 degrees to the plane. You name it as some plane B, E,
40 degrees, sir.
40. 40 ಕೊಟ್ಟಿದ್ದಾರಾ? Okay, sir. If it is 40, 40. Okay, no problem. You take an inclination as 40 degrees. So this is the inclination which is with respect to the x-axis. So if it is x-axis, the theta will be equal to 90 minus theta. Keep that in your mind, very important. If that goes wrong, the problem is wrong. The cross-sectional area of the bar is given. A is given, then directly they are given the normal stress, and directly they are given the tangential stress. Right? All three are given. Anything else is given? Angle on the oblique plane is given. So angle on the oblique plane, theta will be equal to, or you can call this as some phi anta ತಗೊಬಹುದು. Phi anta ತಗೊಂಬಿಟ್ಟು 40 degrees. So that will be equal to 90 minus 5. Theta will be equal to 90 minus 40. It will be 50 degrees. Right? So these are the given data. It is a direct data. So you need to find the stress acting, determine the safe value of P. You need to find the load P, right? So what is the equation for normal stress? It is only a single stress is acting on a component, the first derivation, last class what we done. So that is the equation, those equations you need to use. Normal stress. So if anybody has written, you can tell sigma n, it is given by what? A tangential stress equation. What is sigma n and what is sigma t? It is for, in the last class derivation, what we done? Sigma n is given by
theta.
Sigma into cos square theta, right? Sigma into cos square theta. What is sigma t? Tangential stress.
Sigma by 2 into sine 2 theta.
Yeah, sigma by 2 into sine 2 theta. So here theta you substitute, that is 90 minus 5, that is 50 degrees. So this step, it holds good on throughout the problem what we saw, right? So theta to be 50 degrees. If you substitute 40, your problem will be wrong. Then, so here sigma n is given, sigma, all the things are given. You find out sigma. You find sigma. And you find sigma here also. In both the condition you find. So what is the value of sigma you will get, right? So you will get two values of sigma. You will get two values of sigma, right? Then for what they are given, determine the safe value of P. Safe value of P. So ಇಲ್ಲಿ ಎರಡು value ಬರುತ್ತೆ. You will get two values. So you will get sigma here one value and sigma here one more value. For safe value, for safe condition, use least value of sigma to find load P. So whichever least you will get here. So if the least load is acting on a component, the component will be safer by that condition. If the load is lesser, the component will be safer by using that condition. So whichever less you will get, use that. You know that sigma is equal to P by A. General equation, find out P. That's it. Simple. The only thing you need to know the equation. That's all. Okay. So this you do it. So next class we'll do one more derivation and problem. Well, download the attendance. I'll upload the video also. You can refer to the video. Somebody has missed. So all the classes will be at 8:30 only. So we have some other work. So this week class will be scheduled at 8:30.